6.7 Applications of Sinusoidal Functions. So the following is showing a Ferris wheel in China. So we're going to figure out some of the characteristics of this graph. So first of all, we have the max. The max is at 160. And we have the min, and it is at 2. Thinking that through, why is the minimum at 2 and not at 0? Well, that's because the Ferris wheel does not touch the ground, because if it did, that would be a bad thing. But we do know up here is at 160. Okay, so we can find the midline. The midline is going to be 160 plus 2 divided by 2. So it's going to be at 162 divided by 2, which is 81. So that's kind of our midpoint here. We can also find the amplitude. So the amplitude is going to be the max, subtract the mid, so it's going to be 160 minus 81, and that would be 79. So my amplitude is 79. And what that represents is this portion right here, 79. And if you look at that, that is the radius of the Ferris wheel. So the radius is 79, it's that amplitude, which means that the diameter would be double of that, which would be 158, which is the maximum subtract that minimum. We can also tell the period length. It goes from 0, and the next time it hits the minimum, it's at 30, so that means it's 30. That represents minutes. It takes 30 minutes to go around this Ferris wheel. So using that, we're going to do the next question where we have to make an equation. So the following information is for a Ferris wheel. People riding capsules, the wheel has a diameter of 150, one revolution is 32 minutes. It reaches a maximum height of 165. So let's draw this diagram. Wow, I did not need to draw it that big. Okay, so we know that the diameter is 150, which means that the radius is 75. It has a max of 165. We can figure out the minimum easy. So the minimum is going to be 165 subtract 150. So this right here is 15. It starts 15 meters off the ground. So if I imagine this graph, you're going to start at the bottom. You're going to get on the Ferris wheel here. It's going to start here at 15, and it's going to hit the maximum, 165, and then it's going to hit 15 again, and the time it takes to do that is 32 minutes. So if I wanted to figure out halfway through where that maximum is, I would divide that by 2. It would hit it at 16 minutes. Alright, so we can find the midline now. So midline is going to be the max, 165, plus the minimum divided by 2, which is 180 divided by 2, which is 90. So that is in there, so that is my value for D. To find my A value, I'm going to find my amplitude by taking the maximum and subtracting the midline. So if I take 165 minus 90, I get 75. Remember from the last example that the amplitude was that radius. Alright, our period length. To find our B value, we're going to take 2 pi and put it over 32. We can simplify that to be pi over 16. And our C value, the first time it hits the maximum is going to be 16 minutes. So we can use that to figure out our cosine function, because it's easy to figure out when they're going to hit the maximum first. So our equation is going to be y equals 75. It has to be a cos because we're dealing with a maximum. pi over 16. X subtract 16 plus 90. So there's an equation for that Ferris wheel. It also is asking us to estimate the height after 20 minutes. So we can easily do that by plugging 20 into our calculator. So let's plug a 20 in for x. So 20 subtract 16 plus 90. I would simplify that bracket. So 20 subtract 16 is 4 plus 90. And then just try typing this into your calculator. So I want you to pause it, type it into your calculator, and I'll tell you what you should get. Remember, because we're dealing with real life problem, you should be using radians. The number you should get is oops, it should be y, not x, 143.03 meters. So that makes sense. It'd be somewhere in here at 143 at 20 minutes. Awesome. Okay, so that's how you use your equation. If you did not get that in your calculator, let me know. We can work on that together. All right, similar. Next question. A piston moves in a vertical cylinder. So it's like a line, and then it goes around in a circle. That's what it does. I can't really show you. You're just going to have to trust me here. So it starts from its minimum height, and then it hits. It repeats its cycle every 20 seconds. So let's graph this. I don't even know what I'm doing. I'm just guessing. Okay, so we know that the period length is 20 seconds, which means it's going to hit its maximum halfway there, which is 10 seconds. We know it hits a minimum height of 15 centimeters and a maximum height of 35. So we can figure out our midline. So 35 plus 15 divided by 2 is 25. So here at 25 is the midline. That's not even straight. Whatever. So A, B, C, D, our midline is 25. Our amplitude is going to be 35. Our maximum, subtract our midline. So our amplitude is 10. That is our A value. It repeats the cycle every 20 seconds, so 20 seconds is our period. So I will do 2 pi over 20, which is pi over 10 for my B value. And to figure out our function, because I can see where it's going to hit the first maximum, I'm going to do a cosine function, and I know it's starting 10 seconds to the right. So my equation is going to be y equals 10 cos pi over 10 x minus 10 plus 25. And it has to be cosine because it's where we start at the first maximum. Okay, it also asks where will it be after 26 seconds, so let's plug that in. So 10 cos pi over 10, 26 minus 10 plus 25. I want you to pause the video and figure that out. So the number you should get is 28.09. And that's done. All right, last question. The following is data from the tide heights every 2 hours starting at St. Andrews PEI in March of 2011. Okay, so I'm going to look at this data, and I'm noticing that I hit 6.5, which looks like a maximum, and then I'm hitting another maximum. So I'm going to use that for my data. So max to max, which is 1 period length. So I'm going to say that my max is 6.5, which means then that my minimum is this smallest number, so my minimum is 1.4. And I'm going to make an equation based on this that's not going to be perfect, but it's going to be pretty close. So our midline is going to be equal to 6.5 plus 1.4 divided by 2. So 6.5 plus 1.4 divided by 2 is 3.95. So A, B, C, D. D is 3.95. All right, amplitude. We're going to take 6.5 and subtract that midline. And I get 2.55. So that is my A value. My C value, so think about this. It goes max to max. This is going to be a cosine. We're doing a lot of cosine functions here, I'm aware. It hits the first maximum 2 to the right, so 2 hours in, so that's my phase shift. And my period length is the difference from 14 and 2, so 14 minus 2 equals 12, so it's hours. So to find my B value, it's going to be 2 pi divided by 12, which is pi over 6. All right, so make our equation. It's going to be 2 y equals 2.55 cos of pi over 6 times x minus 2 plus 3.95. All right, so that's an approximate equation for this graph. The question says estimate the tide height at 1700. So we're going to plug a 17 in because it's 17 hours past midnight. So we have y equals 2.55 cos of pi over 6. And we're going to plug in 17 minus 2 plus 3.95. I want you to pause the video and try to get this number. You should get 3.95 meters. And that is the end of our graphing trigonometry unit. Also, I just think it's very important for you to know that this is the very last Pre-Cal 30 video that I had to make for the course. All of the other ones are done at this point for me. And I've been working on this for 24 straight hours, I think. And I just feel like I need to leave this video in the most appropriate way by quoting the best queen of all time. Miss Vanjie! Miss Vanjie! Bye!